Welcome to Math TV with Professor V. This is video lecture for college algebra on section 1.2 quadratic equations. So a quadratic equation is an equation equivalent to one of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a cannot be equal to 0. Otherwise, it wouldn't be quadratic. So the difference from the equations we're going to be solving in this video versus the last lesson is that now our variable is going to be squared, not just to the first power. Okay, that's what makes it a quadratic equation. So we're going to look at two ways that you can solve quadratic equations. The first one is by factoring. That's the easier method. That one's more straightforward. So you want to try factoring first. And please keep this in mind. Note of caution, always set the equation equal to 0 before factoring. Because the whole point is you want to use the zero product property, and you can't unless the equation's equal to 0, okay? Yes. So here we go. Example 1 says solve each equation, and we're solving by factoring. So we have to be obedient. X squared minus 25 equals 0. We're going to factor. Left-hand side, x squared minus 25. Right-hand side, we've got a 0, which is good. So we can start thinking, how do we factor x squared minus 25? Well, it's a difference of squares. So it's going to factor into conjugate pairs, x plus 5, x minus 5. And then this is equal to 0. The whole point of having a 0 on the right-hand side is for this next step here. So if x plus 5 times x minus 5 is equal to 0, then by the zero product property, either x plus 5 is 0 or x minus 5 is equal to 0, or both. You can't do that with any other number. That's why it's called the zero product property. The 0 is essential. And then from here, you've got two cute little linear equations. You just got to solve them. So subtracting 5 from the first one, we have x equals negative 5, or I add 5 here, x equals positive 5. Okay, we don't have any restrictions, so those can both go in our solution set. You can list them separately, like this, negative 5, 5. Or if you're feeling like being efficient, a little fancy, you can just put plus or minus 5. That's cool too. Okay. Now you might be saying, oh, I know another way to solve the equation. I move the 25 over, I take the square root. That's cool, but the directions said to solve by factoring, so we got to be obedient. Yes. Okay, example B, we have 3x squared plus 5x equals negative 2. No, don't start factoring just yet. Remember, we need a 0 on one side of the equation. Usually the right side of the equation is where I like to put the zeros. So add 2 to both sides. Now we have 3x squared plus 5x plus 2 is equal to 0. Okay, good. Now from here, you can factor either by the AC method and splitting the middle term if you need to, or I just do guess and check. So I set it up. I think to myself, all right, 3x squared. The only way to get 3x squared is with 3x and x. Yes? Good. 2. Only way to get a 2 is 2 times 1. So we just got to figure out, does the 2 go here and the 1 go here, or is it the other way around? So you just check in your head what works. Since I want 5x in the middle, then I'm going to want, 3 times 1, 3x times 1 and 2x right there. That'll give me my 5x. So we're good, everything's positive, plus, plus. Okay, good. Then from here, set each factor equal to 0. So 3x plus 2 equals 0, or x plus 1 equals 0. So 3x equals negative 2, x is negative 2/3, or x equals negative 1. Okay. We didn't talk about restrictions, but there aren't any so far, so I'm not stressing. I will start stressing in just a moment. Okay, good. So let's move on here. Now these are kind of maybe reminding you of the equations in the last lesson. So we have 5 over x plus 4 equals 4 plus 3 over x minus 2. So yeah, to start off, we do have restrictions. Remember, we don't want our denominators to be 0. So x plus 4, what would make it 0 if x was negative 4, right? So x cannot equal negative 4. This 4 here is not bothering me. It has no variables in the denominator. And then x minus 2, I don't want that denominator to be 0, so x cannot equal positive 2 either. So those are our restrictions. Okay. Now, second step, think back to the steps that we had in the last lesson. The first two steps always apply. We're going to multiply through by the LCD to get rid of fractions. So the LCD is just going to be x plus 4 times x minus 2. Okay, and I'll write everything nice and spread out so you can multiply through by the LCD and see how everything cancels nicely. Okay, 3 over x minus 2. So everybody gets multiplied by x plus 4, x minus 2 in the numerator, remember. And the goal is to be fraction free in the next step. So let's see. X plus 4 cancels. So I just have 5 times x minus 2. Looking good so far. Equals. Nothing cancels here. That's fine. I mean, there was no denominator. So 4 times x plus 4 times x minus 2 plus, what's going to cancel here? The x minus 2. Bam. Bam. So I just have 3 times x plus 4. All right, now we got to clean up, distribute. So this is going to be 5x minus 10 equals. Now please do this carefully. When you have one little term out here, a monomial, and then you've got these two little binomials, two factors to multiply, you multiply this all out first, then distribute the 4 after. Okay, the little loner outside, he's last. I know, so sad. Okay, so we've got 4 times, this is going to be x squared minus 2x plus 4x, so plus 2x, and then minus 8 like that, plus, and then just distribute 3x plus 12. Okay, good. Keep cleaning up. So 5x minus 10 equals, I'm going to distribute the 4 now, so 4x squared plus 8x minus 32, yeah, plus 3x plus 12. Okay, let's combine some like terms. It's looking messy, I know. 5x minus 10 equals 4x squared. Then here we've got 8x plus 3x. That is 11x. Then we have minus 32 plus 12, so that's minus 20. Okay, we need to set everything equal to 0 before we can start factoring. It's not a good idea to factor with x squared having a negative coefficient. So I'm just going to move everything to the right because I don't want this to become negative by moving it to the left. You get what I'm saying? Okay, good. So minus 5x plus 10, minus 5x plus 10. This is gone. Now I have 0 equals 4x squared plus 6x minus 10. Okay, before we start factoring, I'm noticing I can take out a 2 from everything on the right-hand side. Right? 4 divides by 2, 6 divides by 2, 10 divides by 2. What I'm going to do to make life easy is divide the whole equation by 2, because guess what? 0 divided by 2 is still 0. And then we have 2x squared plus 3x minus 5. That's going to be so much nicer to factor, and you'll still get the same solutions, right? So let's try to factor here. 2x squared plus 3x minus 5 equals 0. So we have 2x and x. I want 3 in the middle. 5 is going to be 5 times 1. So let's put the 1 here, 5 here. That should be positive. Okay, if you're struggling with guess and check, then your other option, I'll write it out this way, 0 equals 2x squared plus 3x minus 5. Remember, we called the coefficient on x squared a, this is b, constant is c, and then you can do the AC method and split the middle term. So a times c goes in the top, air conditioner usually is upstairs, -10, that's not necessarily true, just helps me remember. Okay, and then B, here's your basement, 3. Can you think of two numbers that multiply to -10 and add up to 3? So what multiplies to 10? 1 and 10, that's not gonna add up to 3. 2 and 5, yes. So since it's a -10 and a +3, we would have a -2 and a +5. And then what do? You split the middle term with those numbers. So we have 0 equals 2x squared minus 2x plus 5x minus 5, right? If I were to combine these, I'd get back my 3x. So haven't done anything illegal. Then when you have 4 terms, you factor by grouping. So for the first 2 terms, I can take out a 2x, and I have x minus 1 left. And then from 5x minus 5, I can take out a 5, and I have x minus 1 left. And then as long as you did everything right, this will always work out where you have a common factor here that you can take out now. So we have x minus 1 times 2x plus 5, which is what I got when I did guess and check. Okay, it's strategic guess and check though. If you need a review on how to do this whole AC method and splitting the middle term, I'll link a video here all on factoring. Okay, from this point now we do the zero product property. So x minus 1 is equal to 0, or 2x plus 5 is equal to 0. That means x is 1, or 2x is -5, which means x is -5 halves. So were either of those restrictions? Let's see, -4 and 2. Nope, those are not restrictions. So then I'm going to go ahead, put them in my solution set. My solutions are 1 and -5 halves. Okay. Now, I told you we were going to do 2 methods. The other method involves the quadratic formula. And it's very useful because not every quadratic equation factors. So, you're going to just have to memorize it if you haven't already. Just like with factoring, you need to make sure that you set the quadratic equation equal to 0 first before you use the quadratic formula, okay? So x equals, when I read it out loud, I say the opposite of b plus or minus the square root of b squared minus 4ac, and then be careful that you divide the whole thing by 2a. All right, so one little warm-up I threw in, an extra one before we look at kind of the spicier college algebra level ones coming up. So solve this equation. We're going to use the quadratic formula. Before I get rolling though, I got to set it equal to 0. So let's subtract 13. So x squared minus 6x minus 13 equals 0. Let's list out what a, b, and c are, okay? So a is the coefficient on x squared, it's just a 1. B is the coefficient of x, it's -6. And c is the constant, -13. Okay, always put what your variable is, in this case x, equals opposite of b, so -6, plus or minus the square root of b squared, so -6 squared, minus 4 times a, which is 1, times c, which is -13. All over 2a, 2 times 1. Okay, then we just clean up. So this equals +6 plus or minus square root. -6 squared is going to become +36. And then watch this. -4 times 1 times -13 is going to give me a positive number, right? So 4 times 13, that's 52. And then this whole thing gets divided by 2. Now the next step, you're always going to clean up underneath the radical. So this is 6 plus or minus square root 36 plus 52, that's 88, okay, over 2. We got to make sure we simplify our radicals. So 88, that's 4 times 22. So that's 6 plus or minus square root of 4 times 22 over 2. So this is going to be 6 plus or minus. Remember, you can break up that radical. Rad 4, rad 22. So 2 rad 22 over 2. And then we can cancel out a 2 from everybody. Please do so carefully. I'll show you 2 options. You can split the denominator, so you could write this as 6 over 2 plus or minus 2 rad 22 over 2. And then you end up with 3 plus or minus, this is gone, rad 22. That's one way. Other way, factor out a common factor from the numerator, the greatest common factor. I can take out a 2, and then I'm left with 3 plus or minus rad 22 over 2. Cancel, cancel. And then this is the same thing that we got here. All right. What I don't want you doing is right here just slashing out the 2's like this, because you'll probably forget that you also have to cancel out a 2 from the 6. Like 99% of students who just do this little quick method forget about this guy, okay? So either split the denominator like this or factor. This is probably the better way, okay, to do it. So that's it. There were no restrictions. These are our solutions. And notice we couldn't have factored because we have an irrational solution, that radical 22. So we had to use the quadratic formula. Factoring is typically faster and easier whenever your equation factors. But quadratic formula will work for ones that factor as well. Okay, so moving on now, let's look at a couple more tricky ones. First thing here, example 3a, we have 2/3 x squared minus x minus 3 equals 0. Now there's no restrictions. I know I have a denominator, I know, but it's just a constant. There's no variables in that denominator, so we don't have to stress about restrictions. So I'm just gonna get this thing fraction free. I'm gonna multiply everybody by 3, the LCD, before I use the quadratic formula. Yes. So 2/3 x squared times 3 is just going to be 2x squared. And then we're going to have minus 3x minus 9. And 0 times 3 is still 0. So let's list out what a, b, and c are before we get rolling. So a is 2. B is negative 3. And then c is negative 9. All right, so here we go. X equals opposite of b. So that would be positive 3. Plus or minus the square root of b squared, so negative 3 squared, minus 4 times a times c, so 4 times 2 times negative 9, all over 2 times 2. Nice. So this is going to be 3 plus or minus square root, that's 9. And then since I have 2 negatives here being multiplied, it's going to turn into positive. 4 times 2, that's 8 times 9 is 72. Over 4. So this is going to be 3 plus or minus square root. 9 plus 72, that's 81 over 4. Well, square root of 81 is 9, isn't it? 3 plus or minus 9 over 4. Do you leave it like this? No, because we don't have a radical stuck in the equation. 3 plus 9 is 12 over 4, or 3 minus 9 is negative 6 over 4, and those reduce. So we get either 12 over 4, that's 3, negative 6 over 4 is negative 3/2. We had no restrictions, so those go in the solution set. So notice here, since our answers were rational numbers, we didn't have something like rad 23 left over like last time. We actually could have solved this one by factoring, but we're just practicing the quadratic formula right now. So just pay attention when you're working on your exercises or you're doing problems in class or on a test. to use the method that the instructor says. If they let you pick, then you pick. Okay, B, 2x over x minus 3 plus 1 over x equals 4. So we are going to have restrictions here. X cannot equal 3 or 0. Are you guys getting more comfortable finding the restrictions? And then I do want to clear out the denominator, so I want to multiply by the LCD. The LCD is going to be x minus 3 times x. So let's rewrite everything. 2x over x minus 3 plus 1 over x equals 4. Then I'm going to multiply by the LCD, so x minus 3x, x minus 3x, and then one more here, x minus 3x. Okay, cancel, cancel. I just have 2x times x, so that's 2x squared, plus, let's look at the next term, x's cancel, so I just have 1 times x minus 3 equals, I'm going to write this as 4x times x minus 3. You guys cool with that? Okay, good. So let's clean up and then set equal to 0 before we start figuring out a, b, and c. This is going to be 4x squared minus 12x. And typically you don't want a to be negative when using the quadratic formula. It just makes life so much more complicated. So I'm going to have a 0 on the left-hand side. So I'm going to subtract 2x squared, subtract x plus 3. Subtract 2x squared plus x plus 3. Bada bing, bada boom. So now we've got 0 equals 2x squared. Let's see here. Oh, I should have subtracted x. Forgive me. Minus x. So that'll be minus 13x. Plus 3. Okay, now we can identify a, b, and c. So a is 2, b is negative 13, c is 3. Why don't you pause the video, see if you can do this next part on your own, plugging in everything and simplifying. Okay, did you try? I hope you did. So x is equal to opposite of b plus or minus square root b squared, negative 13 squared is going to be positive 169, yeah? Minus 4 times a times c all over 2a, 2 times 2. So we're going to have x equals 13 plus or minus square root. That's 169 minus 24, so 145 over 4. And actually, radical 145 doesn't simplify, so we're done. So let me just erase this and then put a nice little solution set on it. Neither of those were our restrictions. Our restrictions were 3 and 0, so we're in the clear. Okay? Good. So one last topic that we're going to study now is the discriminant. And the discriminant of a quadratic equation is the expression b squared minus 4ac. And your book uses this symbol here, which sometimes, you know, refers to change or delta. So I don't know why they're using it for the discriminant, but whatever. Maybe because they got tired of writing discriminant. It's basically the stuff or the expression underneath the square root sign in the quadratic formula. So let's look back at the quadratic formula that we had in our notes. This right here is the discriminant, just that part underneath, without the square root. So if they ask you to find the discriminant, you're just finding this part right here that I'm circling. Okay, so here's some things to keep in mind about the discriminant. It'll tell you what kind of solutions you're going to have. So basically, if it's greater than 0, if it's positive, then your equation has 2 different real solutions. Like here, 3, negative 3 halves. What was the discriminant? It was 81. We love it. If the discriminant is 0, the quadratic equation has a real solution of multiplicity 2. I'll show you what that is going to look like because it can be a little confusing. And then third is if the discriminant is less than 0. So if it's negative, then the quadratic equation has 2 different complex solutions. meaning it has no real solutions. We're going to work on figuring out what those are later. But basically that's because if you have a negative quantity underneath the radical, if this stuff's negative, then you won't have a real solution. You'll have a solution in the complex field of numbers. So it'll involve the imaginary unit I, which we're going to study coming up. Okay? All right. So don't stress. The homework exercises or the problems that you do with the discriminant aren't too bad. Look what the directions say. Use the discriminant to determine whether each equation has 2 real, 1 real, or 2 complex solutions without solving the equation. So you're not solving, you're just finding the discriminant and then saying, are you in case 1, 2, or 3? That's it. Okay? So here we can use delta since they're so keen on it. A is 1, B is 4, and C is 7, right? Everything's set equal to 0. So delta, or the discriminant, equals B squared minus 4 times 1 times 7. So this is 16 minus 4AC. So that's going to be 4 times 1 times 7, that's just 28. Okay. So 16 minus 28, I mean, I don't really care what it is. I already can tell it's negative. It's less than 0. So I'm in this scenario, case 3. Don't put case 3 though. I mean, that's just what your book calls it. So you have to say that we have 2 different complex solutions or no real solution. Okay, good. Let's look at the next one, example B. A is equal to 2, B is equal to negative 3, and C is negative 7. So discriminant is going to equal B squared minus 4AC. So this is going to be positive 9. And then since we have 2 negatives here, this is going to be plus 4 times 2 is 8 times 7, 56. So 9 plus 56, that's going to be 65. That's greater than 0. So what does that tell me? I'm in case 1 where we have 2 different real solutions. Okay, one more, C. Let's do x squared minus 10x plus 25 equals 0. So let's list out what A, B, and C are. A is 1, right? B is negative 10, and then C is 25. So discriminant, B squared, negative 10 squared. Are you putting the parentheses nicely like I am? Watch, pay attention. You have to put the parentheses around the negative 10 and the exponent goes outside. That way you know that it's going to become positive, right, after you square it. Minus 4 times A times C. So negative 10 squared, that's 100, minus 4 times 1 times 25. Why, that's 100 as well. So this is 0. When the discriminant is 0, remember that's that second case where you have a real solution, multiplicity 2. And I want to show you what that means, okay? So the equation was x squared minus 10x plus 25 equals 0. If you were to try to solve, let's say we're going to solve by factoring, not the quadratic formula, this cute little guy factors. It's going to factor into x minus 5 times x minus 5, right? Good so far? Okay. And then you do zero product property, x minus 5 is 0. But wait a minute, this is the exact same thing. So you get x equals 5 twice. That's what it means that it's multiplicity 2. And you don't write it twice, you know, that's pointless. So usually you just put it in the solution set by itself once. But we know it's a quadratic equation. It's going to have 2 solutions. So since it's in there twice, it counts as double, basically. And another cool way to kind of think about it is you don't have to factor writing x minus 5 twice like that, right? Couldn't we have written it as x minus 5 quantity squared? And that little exponent, that tells me the multiplicity, it's 2. So that solution is in there twice. That's what it means. And that happens with the quadratic equation anytime the discriminant is 0. That's how you know you have that special case where you got that double root or double solution. Okay? So I wanted you to see one of each. And then don't worry, later on you're going to look how to solve the ones that have complex solutions so you can feel really fulfilled and proficient. So give the video a thumbs up if you found it helpful. Stay tuned. We're going to look at solving more equations pretty soon.